Today's lesson, section 3D-A, we're talking about surfaces in 3 space. So this begins our 3D conics unit, where we're going to graph all the kind of conics that we talked about in chapter 11, but we're going to do it all in 3D. So you're going to have kind of the same look as what we talked about with our vectors. But here it's going to be a little bit more difficult to graph. So it's okay if your pictures are not pretty and perfect. It's alright. Mine are not going to be either. Some of yours will look really good, but it's not a big deal. It's just all about just being able to conceptualize and put things into perspective in the 3D space and understanding how those should look. And now we're going to use different tools to help us do that. And so I still have that 3D paper that you can use, or the isomorphic or dot isomorphic paper that you can use to graph your 3D shapes. Also, this is where the 3D grapher on your computer really comes in handy. So remember, just go to the magnifying glass in the top right corner, just type in grapher and it should come up. And then when you open it up, change your axes to 3D. If you have trouble seeing stuff, I've figured out how to change the colors of the background so that you can kind of see things a little bit more clearly and it makes a little bit more sense. So hopefully we can get better at using the grapher as we move forward, so that it'll become a nice tool to help us conceptualize, because our brains usually don't see things in 3D, and some people do, so this might be easier for some kids, but it might be very difficult for other students, and I understand that. So just make sure you ask a lot of questions. If you need the help, I will do my best to help you out with this. Okay, so here we want to be able to graph an equation in 3 variables, and it's normally a surface. Now when I say a surface, I mean like it has there's a solid ground. Like if you were a mini person on these 3D places, you could actually stand somewhere on them, depending on how whatever gravity would be becoming on these spaces. But just surface means that there's a place to actually you could be on or touch, making it a 3D shape, basically. So that's what we mean by surface. We've already talked about 2 surfaces, and so we've talked about a plane, and there's that equation, and then the sphere, and both of them we discussed in chapter 9 when we were talking about vectors. We graphed planes, we kind of graphed some spheres. We didn't really go super deep into graphing the spheres, but just so you know that you've been down this road, you know what they should kind of look like, so it kind of gives us a starting point. Now, to graph surfaces in 3D, we need to find intersections of the surface with well-chosen planes. And so what I mean by well-chosen planes, most of these, or basically all these conics, we're going to be at the center or their origin. Okay, so we're not going to be moving them, like shifting them or rotating them really. So you don't have to worry about that. We're just going with the basic, just so we can kind of get a good idea of what these should look like. So well-chosen planes are going to be the main ones, so in the coordinate planes. So you have your XY plane, your XZ plane, and then the YZ plane. Okay, so that's what I mean by well-chosen planes, because those are the nice ones where a lot of stuff, or one of your values is 0, 0, and it gets us a good look, and then we don't have to do a lot of number crunching to kind of figure out what it's supposed to look like. Okay, now these intersections are going to be called cross sections, and I'll probably use cross sections. I think some of the stuff may use the words plane sections. I just think that's kind of hard to understand, but cross sections to me means that these are where planes cross your surfaces, so they're the crossing or the intersections of the two that we're talking about. And so if they are in the coordinate plane, so in these planes x, y, x, z, y, z, you can also call them traces. And I usually call the trace like the outline, or like where the trace is actually where the plane intersects the surface, so that the picture that's created when they intersect one another. So this is just my 3D conception of a cross section and what we're kind of talking about. And so here I have like a parabolic bowl, and I just take a cross section of it, cut it in half, kind of, and then that leaves you with this U shape, which is a parabola, right? And that's what you should get when you're talking about a cross section of a plane, and a parabolic, or a paraboloid is what we'll call it, okay? But that's kind of what conceptually we'll talk about, okay? So now I kind of want to show you how we graph these. The assignment for this is very kind of more so the beginnings, and so stuff that we've already talked about, where like if I have a plane in this certain level, what's a certain point that you would find, or so kind of things that just get you back into the mindset of 3D-ness, okay? But I do want to kind of start talking about what graphing would look like. So here I have an ellipsoid equation. So I have x squared over 16 plus y squared over 25 plus z squared over 9, which equals 1. So how I would graph, like I said, I'm going to use well-chosen planes. So I'm going to look at my traces, where cross-sections happen in the xy plane, the xz plane, and the yz plane. Okay, so if I plugged in 0 for z, that would leave you with the equation x squared over 16 plus y squared over 25, which is equal to 1. Now, think about that equation in 2D, because that would be an ellipse. Okay, it's got two squares, there's a plus, that's an ellipse equation. Okay, here, if I plug in 0 for y, you would get the equation x squared over 16 plus z squared over 9 is equal to 1. That would also be an ellipse. And then if I plugged in 0 for x, then you would get the equation y squared over 25 plus z squared over 9, which is equal to 1. It's also an ellipse. So here, three traces create these ellipses, and that's how I get the picture of an ellipsoid. And I have a 3D grapher picture in the next slide, so you can maybe hopefully better see what it should look like. But here I'm going to try to show you how I would graph this, just to kind of get you used to this thought process. So I'm going to graph the 2D shapes, and then I'm just going to combine them visually. Okay, so let's take the first one. So in the xy plane, you have an ellipse where your A is, or it looks like your A is 5, and your B is 4. So, now let me use, so I don't get too many colors going on here. Okay, so I kind of just go with the vertices for the shape. So here's my major axis, here's my minor axis, and now when I graph this, now I want to kind of make it so it looks a little bit more 3D-ish. Okay, so that's an ellipse. Now this is an ellipse at a slant, and it's hard to kind of tell like the actual shape that it should be, but that's what I'm going to show. So let's pick a different color here and just make our Z's though. Now it's not going to be super accurate because I'm not perfect with my numbers or my graphing. So if I do one in the XZ plane with green here, so then now my major axis is the 4s, which I already have graphed. Okay, so you have those. Okay, and then you also have the Z's. there and there. So 3 and 3. And then let's do a different color. So purple for this last one. So then you've already got these met and these drawn. Okay. Now you don't have to regraph them. Once you have them all graphed, it should be nice. So now I want to actually trace the ones in the XZ plane. So then here I want to kind of try to make it look like an ellipse in that, so it's slanted that way. And then also you've got one in the YZ plane. Now this one will be more 2D-ish, so it'll look more like a ellipse that you're used to seeing. Okay, and so now it looks like just a bunch of lines, but sometimes you can kind of, and I'll probably make this look worse, just using a different color. You can make traces of circle, like your ellipses all the way around, connecting your points. So I kind of like to start with the middle and kind of go that. And sometimes I'll just leave it alone. If that helps, that's fine. If it doesn't, you can just not do it. Okay? And you can just leave it like this. Some kids are very good at shading these so that they look like they're supposed to, but sometimes you just can't make it look the right way because some of the hyperboloid ones that we do, it's hard to kind of see what the shape should be. So that's where the 3D grapher kind of comes in handy. So here I grafted this. Okay, so this is the shape. Okay, and I put this into the 3D grapher, came up with this picture. You can change the colors, you can change the background. I marked the axes so you can kind of see what the shape should look like for the most part. But that's basically the full surface of the 3D grapher, or the 3D ellipsoid is what we would call this particular surface. Okay, and now for your assignment, you kind of need to know these formulas. I didn't do any examples with these because I know you know how to already do midpoint and distance formula, because we've done it lots of times with distance formula, and so I didn't think I needed to do any extra ones because I know you know how to do those. But I just wanted to post them there so you knew that you were going to need to use them for your assignment. Okay, so have fun, and if you need more help with these, or when we get to, like, I think it's 3D-C worksheet, when we start actually graphing them, let me know. We'll do as many pictures as we possibly can. It's hard to do on here, but I'll try to insert in pictures using the 3D grapher so you can kind of conceptualize them and match them up, because it kind of makes it a little easier to comprehend what's going on. Okay? Have fun.